spent about a third of your life working on this mission. What are you feeling now?
It's a pretty amazing emotional state when you get to a point like this in your career, an event that you've worked for, in my case, over 16 years to get here. You kind of think back to all the people who have helped you.
OSIRIS-REx is 3 missions in one to make that kind of exploration cost-effectively for not much more than the price of a blockbuster movie.
As OSIRIS-REx was actually out in space and began making its approach closer and closer to the asteroid, it used its suite of onboard camera instruments to actually image the surface in increasing detail. Bennu grew in detail from just a few tiny pixels on our screen to this super high-resolution world littered with giant rugged boulders.
Bennu is a totally different creature. It really looks like a pile of rubble.
There were obviously a lot of firsts in this mission, and there was a time when you said, a lot of what ifs, basically. What if we could actually send a spacecraft to an asteroid? What if we really could bring back a sample of the solar system from billions of years ago?
But it's always really rewarding, like even when you saw the first, approach picture to Bennu, it's like, oh my gosh, that's our target.
The TAG is just the pinnacle of the mission so far. Getting the sample back to Earth is obviously going to be the great event of the entire mission.
I think one of the age-old human questions, perhaps going back to the beginning of humanity, is, are we alone in the universe? And that maps directly into, why are we here?
We want to understand the origin of the Earth, the origin of the Moon, the other terrestrial planets, but the earliest histories of those bodies is wiped out. We had the late heavy bombardment 500 million years after solar system evolution, and that's what dominates the surface of the Moon. The Earth is a very active geologic body. You've got volcanoes, you've got earthquakes, you've got the hydrologic cycle. It's reworked the surface many, many times, and we worked very hard even to go back 3 billion years to understand what happened in that period of our planet's history. The asteroids record the earliest stages of the solar system, from even events that took place before our solar system formed, the stages of protostellar collapse and the formation of the protoplanetary disk, and then the formation of hydrated minerals and organic molecules in the first 10 million years of solar system history. Asteroid Bennu is a time capsule from the earliest stages of solar system evolution.
Our main goal is to collect a sample of an asteroid and return it to Earth. But why was Bennu chosen as the target destination asteroid for OSIRIS-REx? Well, the science team took into account 3 criteria when making that selection. We need an asteroid that we can easily travel to, retrieve a sample from, and return to Earth all within a few years' time.
And then we needed to think about the fact that we're a solar-powered spacecraft. We couldn't get too far out into the solar system. We couldn't get too close to the sun, so that constrained the size of the orbit. So with all of those constraints, we got down to a few dozen asteroids, and then we looked at spacecraft safety. We needed something that was kind of large and not spinning very rapidly so that we could do our proximity operations and get the spacecraft down to the surface and get that sample.
When an asteroid is smaller than those 200 meters in terms of diameter, it actually spins rather quickly. And it can rotate rapidly enough to where even some material could potentially be ejected off the surface. We want this to be a safe, smooth, slow high five of that surface. Our third criteria was composition. Thanks to telescopic observations in the visible and the infrared, as well as in radar, Bennu currently is the best understood asteroid not yet visited by a spacecraft.
So we want to go to a carbonaceous asteroid that's recorded over 4.5 billion years of solar system history. And then finally, after all of that, we had about 5 asteroids left.